So the first thing we're going to look at is our objective here says to use Excel's FV function to compute the value of a savings investment account given the annual percentage rate, the APR, an initial deposit, any reoccurring deposits, and what we call compounding periods and over a specific time. So let's click on the tab labeled FV, and that's going to get us started with this particular objective. So FV stands for future value. So for calculating the future value of an investment or a savings account, these are the types of parameters we're going to be using in our class. Now, this FV function that you see here is a function defined to Excel, and this is going to be how we calculate this compounding interest type of problem. Now, if you were in Math 171, you would be using a whole different formula altogether. But because that is not the objective of this course, the objective of this course is to use this function in order to calculate an end amount. We don't have to go through some of the complex algebra that it may take in order for us to compute such an amount. So these are all of our input values. We have our APR, which is that annual percentage rate. N represents the number of times we have the interest rate is compounded within, let's say, a bank or an investment or so forth. And this would be the number of times it's calculated per year. Y represents the time for the investments in years. PMT represents the payment that would be the reoccurring payment or deposit you might be making into this account. PV, also known as P, is known as the principal amount or the beginning amount. FV, that future value, or A being the end amount. Now, I want you to take note that if the frequency of your compounding number here, so if N and the frequency of your payments don't match up, then we need to use the frequency of the deposits. And we'll see an example like this a little bit later. The other thing about our N values, the number of times that we are compounded per year, these are the kind of words that you're going to see in these problems. You'll see something like yearly or annually. If that's the case, then our N is 1. Semi-annually means N is 2. Quarterly means N is 4. Monthly, our N is 12. Weekly is 52, and daily is 365. And if you have started your Desmos lesson, you probably have already seen this information listed. So let me show you how this is going to work. So basically what we're going to do is we're going to read our scenario and we're going to extract all of the inputs that we need in order to calculate our future value. So let's start by reading and let's extract out the information. So suppose you deposit $8,000 into an investment account at 3.72% interest. It is compounded monthly. If you make no additional deposits, how much money will you have in your account after 10 years? So there's a lot of information in here. So first of all, let's identify our APR. So our APR is 3.72%. The number of times of year it's compounded, it says that it is compounded monthly. So this tells me that our input here is going to be 12. Now, what length of time? It says after 10 years. So this means our Y is going to be 10. It says in the problem, no additional payments or deposits. So this means that this is going to be 0. And then we need our initial deposit or our initial balance. And it says our deposit was $8,000. So these are all the inputs we're going to need in order to calculate our FV. Now, the formula for FV is sitting over here. I'm going to copy this over so I have it next to me. but there's a lot of inputs here, right? So let's just go through it step by step, and then I'm going to show you an alternate way of entering these inputs. But we're going to start by clicking entering in our equals, and then we're going to type FV, and you'll notice that that function is going to open up. And the first thing we're going to start with is a rate. So we're going to highlight the 3.72%, and we're going to divide that by our N. And then we have to say comma, and then N times our Y value. And then we say comma, and then you say minus the PMT amount, or the deposit amount, the monthly deposits. So it'll be minus K11 in this case. And then we have one more input, and that would be to say minus our PV. And then we end our parentheses and hit enter. Now, if I put all of those inputs in correctly, we should get the amount $11,000, 11,900, sorry, $598.39. This is how much would be in this account after 10 years. Now, I know that you're probably working through this and you're like, Ms. Klein, slow down. So I am. I'm going to show you another way of putting this in, because I know that it's very easy to get out of order when entering this in. So another way, an alternate way of entering in our function FV is we'll start out by typing it in, but then we go up to the formula bar and we're going to click up here on that FV where it says insert function. When I do that, notice that an input box appears. This will help us keep all of those values separated. Now, of course, I still need to know what's going to go where. So my FV, let me cancel this out. Let me just highlight this. Here we go. Let me try that again. So we've got, just erase this out. All right. So my rate is going to be APR. So I'll highlight APR, and we're going to divide by our N. The NPR is going to be N times Y. Our payment, we still say negative, and we're going to highlight that PMT value, and then we have negative, and we're going to highlight the PV value, and then we hit OK. So that's another way for you to enter in this information here.
Hey, can I ask a question?
Yes.
Yeah, so when you pull up that, do you have to put in the negative signs in the
Yes.
okay, all right.
If you're ready to move on, can you just give me that thumb up action inside of Teams here? That kind of lets me know. If you select the little emoji guy with the hand up, underneath that there's a thumbs up. Just give me a thumbs up when you're ready to move on. All right, let's take a look at the second one here. So the second example, it's very much like the first one, except that I have that deposit of 8,000. I'm still going to invest it at the rate 3.72%. It's still compounded monthly. It says, but you're going to make an additional deposits each month of $100. So if I add in $100 each month, how much am I going to have in that account after 10 years? So I'm going to copy this formula down again. And when you're starting from scratch, I want you to write the inputs in the order which you see them. So we need to list off our APR, we need an N, we need Y, we need PMT, we need PV, which is the same thing as P, and we need our CV, sorry, FV. It's getting late in the day. My brain is delayed. So these are the parameters I'm going to need. My APR is 3.72%, same as before. I'm still compounded monthly. My years are 10, but now I have a payment of 100, so I'm going to enter that in, and my initial deposit is 8,000. So now I'm going to put my FE function in, and I'm going to do my APR divided by N. Then my second input is going to be N times Y. My PMT is going to be minus, and I'm going to highlight the cell with 100. And then we're going to do minus our PV and hit OK. So you'll notice that I have a significant increase in the amount of money in my account. By adding in that $100 a month, after 10 years, I'm now up to $26,108.02.
I have a question for you.
Yes.
Should we always be using the dollar sign when we're entering in the numbers?
No, you do not have to. I just do it for formatting just so that we have some context about what that number actually means.
Okay, thank you.
But if you do use the dollar sign, I suggest using currency as opposed to accounting. So like right here, if you click on this dollar sign, it's using the accounting,
Mhm.
and there's nothing wrong with using that. I just don't like how it formats the number. Just
Okay.
my preference. Can I do the formula one more time? Absolutely. All right, so let me go ahead and copy what formula comes up here, just so you have it. So entering it in, we're going to type first with the blank cell, we're going to type FV. And then we have to get at least the parenthesis to show that it's a function. Then we go up to our menu bar, our formula bar, and I'm going to click on that FX button. The rate is going to be the APR divided by the N. NPR is the number of times per year. This is going to be our N times Y. My PMT is minus the PMT amount, and our PV is minus PV. Then we hit OK. So a question you might see in this lesson would be, they might ask you to calculate, all right, without any additional deposits, how much would you have in your account after 10 years? And then here we calculated the same information except that we added in $100 over the 10 years. So a follow-up question to this could be, well, how much more money are we earning, or how much more money do we have in our account after 10 years if we deposit that extra 100? And so we see that we have an additional, and we could do a calculation of that, couldn't we, if we wanted to? We have our this amount, subtract off the original amount. We have an additional $14,509.63. Now, it's not asking you that. I'm just kind of explaining what types of questions we could be asking you on this lesson. All right, let's go to the you try. There's two of them here. And I would like for you to try number 1 and then number 2. So once you get your answer to number 1, if you would just post your final answer in the chat, and then that lets me know you're done, and we can move on to you try 2. If you get stuck, just put in the chat, I'm stuck. I'm going to wait for you. That lets me know where we are. I'm going to pause myself, mute myself, I should say, as you work on this problem.
Karen, can I ask you a question?
Go ahead.
So I completed the Desmos, and I noticed that And I'm just trying to get an explanation for it. If you do not enter in the percentage sign, it changes your entire answer.
Yes, that's correct. And the reason for that is so there's two different ways for you to enter in your APR. So either you can put it in as a percent, or you can write it, if you write it as a number, then it should be written as 0.0355. Remember going back to that first unit we had together, remember we would convert percents into decimals before we use them.
Right.
And because Excel is fancy, it can do it for us. All right. Now,
Awesome.
if you're doing it by hand, you will have to convert it to decimal first.
Okay.
So like I could even again, if I turn off the formatting for percentage here and just make it a number, you'll notice that this is really just a decimal in disguise.
Gotcha. Okay.
Yep,
Thank you.
you're right. Good point. Are you guys okay if I go ahead and get started working this one out? So we have 3.55% here. We are compounding quarterly. So that means our N is going to be 4. It says it's going to be how much is in our account after 5 years. So we have our length of time for Y. Now my payment here is 75 and the initial deposit was 2,500. Now I'm ready to write in my formula. I'm going to do it differently this time. I'm just going to type it in based off of what we know about our function. And by the way, this is a formula that we'll give you on the test. However, we're not going to give you all the formulas, so you might as well put this on your formula sheet, your card, your index cards you're going to use for your test. I would say go ahead and put that on there, even though we're going to give it to you on the test as well. All right, so we're going to type in FV parentheses APR divided by our N, comma, N times Y, comma, minus the PMT value, comma, minus our PV value in parentheses. So the amount we have in our account after 5 years compounded quarterly for this percentage is $4,616.70. How many of you got that value?
I did.
All right, excellent. All right, great. All right, go ahead to you try number 2. The problem is going to look very similar, except there is slight difference. So let's see if you can identify what is different about you try 2. And I think it's important for you to practice typing in all of the different input parameters because again, you know, when you go to your test, you don't have a pre-filled worksheet, right? Like you have here. So let's just get into the habit of typing out those values.
Do you know how you have on there the common values for N? Is that something that we should put on our little study format card as well?
Yes.
Or okay.
Yes, I would. Yes. Did anybody else get this huge amount? $152,752.05?
Yes.
All right. And so what was there was only one change between you try one and you try two, yet the end result was significantly different.
It was like the compounded.
Yeah. So the compounded means basically, you know, it means I'm compounding daily. So that means that I've deposited my money. After the first day, they go ahead and pay interest on what you have in your bank account. And then the next day, they pay interest out on what's in your bank account. So basically, it's like I'm sprinkling in more money and then I have to pay interest on that more money. And then the next day, I have more money. And so it is rapidly going to increase pretty quickly. You will also find that you're not going to find a bank that's going to give you compounded daily totals.
It
If you
was
just
just
got to
it was
Yeah, I wanted to ask this. So here it says compounded daily. So if it says compounded monthly, it's gonna be like the number is gonna be 12, right?
Yep.
Okay, all right, because that's where I think I
And if
missed
you
it.
said weekly, it would be 52.
Okay, so then the question comes up again if it's gonna be because remember the first one we did, the thing says compounded weekly. I forgot the question, but
Yes.
then we had to change both of them to line up.
Yes, we do. Thank you for pointing that out.
So
So,
go ahead.
yeah. So we were talking about over here, there was this note right here. It says when the frequency of your compounding, we highlight this here. See, Philip and I had a little pre-discussion before boot camp started. So that's where he's pulling from. So it says when the frequency of the compounding and the payments, like the frequency of your payments, don't match up, they want you to use the frequency of your deposits. So over here for this problem, we actually have more than one change that we need to make here. So right here, because we are depositing monthly, and I guess the same is going to be true up here as well. We're depositing monthly. So we should have brought it up here. Basically, the whole purpose of what I was doing right here was just trying to show you how to enter in the information, but we do have a discrepancy here. So when these two don't match up, we have an issue. So if this is compounded daily, but I am depositing monthly, and again, this is getting into some accounting practices. And so for our class, what we're going to do, just so that we're all consistent, is that I would like for you to use the monthly deposit. So whatever you are paying in for the deposit, that is going to be the frequency that we use. So here, instead of using compounded daily, I'm going to scratch that out and we're going to change this to monthly. And the reason why I'm doing that is because I want my frequencies to match up. So I'm just going to mark this red to show that these two are now matching up. So I'm going to change this back to monthly. And now we have a total amount of $7,900.95. And again, the reason why I'm doing that is because we want our frequencies to match up. And in this course, we're just going to default to the monthly payment. So with that said, and now that we know, I need to go up here and fix this one as well because these are not matching up. So we want to change this one to be monthly. Well, so I'm going to mark out quarterly. You don't have to do the whole scratch out thing. I'm just trying to document For note-taking purposes, I'm going to change this to 12. So we're actually going to have the exact same amount if we are using this methodology.
So then the question comes up is,
Mhm.
if let's say we have a question where it says, okay, quarterly, right, for the first question,
Mhm.
and then the second question goes, let's say question B says, what is it going to look like when you deposit monthly, but same first question, but then the uh, quarterly changes into monthly, right?
Mhm.
So do you make any note? Can you make any note on just to clarify yourself about what we're supposed to be using? Since I'm in.
Absolutely. So from an instructor standpoint, if I give you the difference, I would not give you a monthly deposit. That way you're practicing using different values of N.
Okay,
So
gotcha.
more than likely what's going to happen when you're doing your problems is that you're not going to run into this kind of discrepancy too frequently in our course. It's just the problems that I made up here, it just happened to appear. And so because that happened, we have to make the match, and that's why we change them so that the frequencies are in sync with one another.
So basically, what only changes is if our payment is done monthly, then you'll have to
Correct.
change. Okay.
So if here, like in this one here, if I change this, I'm going to mute you. Hold on. All right, thank you. All right, so if I change this here and it said I had $75 daily, right? Then I could use the compounded daily. So then I would change this back to 365. And that's the reason why I have so much money in that account, because I'm depositing, not only am I paying interest every day, I'm also depositing in $75 daily. So that's the only way that that would stay the same, is if what we are compounding and our deposits are matching up. Does that answer your question, Philip?
Yeah, the
All
answer
right.
is it. Yeah, I just want to make sure that what the question says is what you're gonna put. But then if you're finding, because you can do either way changes the amount.
Mhm.
All right, so daily will change the amount significantly, but if it's monthly, then it will drop it.
Ab-
So
Absolutely.
yeah, just want to make sure that we can have that clarity.
Yes.
Yes. Yeah, thank you.
Mhm. So let's move on to future value that may involve goal seek. So if we move over to our next tab, it says goal seek is going to be used if given a future value, I give you what that future value is going to be, but you have everything except for one of those input values. So for example, I might be missing the APR like it is in this example here, or I could be missing um, the N or the Y or the payment or the initial amount, the PV. So when that occurs, we have to use goal seek. And so I just copied and pasted our goal seek functionality that we had from previous boot camps. So to get to that goal seek, we have to first of all be using an Excel that is downloaded to your desktop. We would select data, what if analysis, then goal seek. And then when we do that, a pop-up box is going to appear, and they want you to set the value of your cell and its to value, and by changing a particular cell in order to compute the goal seek. So what is going to go in each of these inputs? That top input is always going to be the cell with your FV value. The second input is going to be the desired output value amount, like what you want FV to be equal to. And then the last cell is going to be basically you're going to highlight the one that's missing. So we're going to apply this to our first example here. So here I've already inputted my input parameters. So we're going to read the problem and we're going to extract all of our information to put into our table here. It says determine the initial deposit. So they're telling me what they want to find. So we're looking for the initial deposit. So that is going to be our PV. So we're looking for this. They want to determine the initial deposit into an investment account that's using 3.72%. I'm going to go ahead and convert that to a numeric. That is compounded monthly. If you make no no additional deposits, so our PMT is going to be 0. And they're telling us that our ending balance is going to be 15,000. So in the end, your PV is going to be equal to 15,000. And that's going to occur after 10 years. So our missing input is going to be this initial deposit. So this is what we're looking for. So we still have to input our FE function in order to goal seek. So we're going to have our APR divided by our N times our Y minus PMT, comma, minus PV. Even though nothing's there, we still have to highlight it. Now, when I first input in this particular field, we get an output of 0 because I have nothing going into this account. So if there's nothing going in, there's going to be nothing coming out. So we want to find the initial deposit that makes our FV equal to 15,000. So we're going to goal seek this. So again, our set value, so this is going to be what our goal seek is going to look like. So that first input here is going to always be your equation. So in this case, that's K13. The to value is going to be set to 15,000. And we're going to do so by changing K12. And that's our input. And I typed this out so that you can explicitly see what I'm putting in that goal seek. So we're going to go to data, what if analysis, goal seek. And you'll see that because I had my formula box highlighted, it automatically put in K13. So I'm going to put in my 15,000 because that's where I'm trying to get to. And I'm going to do that by changing K12. So my initial deposit needs to be $10,346.27. 10,346.27. So I've got to have majority of the money at the beginning. Latoya, you have a question?
I noticed in the beginning of this problem, you changed it to a decimal, the APR. Is that necessary
No,
in?
it's not necessary if you use the percentage.
Okay, I just wanted to make sure.
Yeah, I'm going to, since you asked me that question, I'm going to be doing it both ways.
Thank you.
You're welcome. So if I went back in and changed this to 3.72%, you'll notice that it did not change a thing. And actually, because that is what's there, you would just write it as a percentage and it didn't change anything. So if you mastered Goal Seek last unit, you should not have any problems this unit with Goal Seek. If you did not master it, now you have another opportunity to master it. All right, so we're going to move on to you try here. I want you to enter in your input parameters. I want you to highlight the cell that we're looking for. This is a goal seek tab, so we know we're going to have to goal seek something. I want you to input the cell, like what the attribute would be to go into each of those inputs, and then calculate what that monthly deposit is going to be. I'm going to give you a minute or two to work on that. I'm noticing this problem here also has that discrepancy, doesn't it? Because they're asking you, how much do you have to deposit each month? So here we're going to have a monthly deposit. So we need to change this to monthly as well. So we're going to change this to 12 so that these match up. So we're going to change quarterly to monthly so that our frequency is matching up.
I have a question here.
Mhm.
So with that quarterly, would there be any question where you will say how much will the payment be in the first quarter or something of that sort where we'll have to put those
We
numbers?
won't have to do that.
Okay.
No. All right, I am working it out. Let's see if we agree so far. So we got two value, 11,000. By changing our input, our month, oh, actually, I typed in the wrong area, didn't I? Sorry about that. Told you my brain is getting tired at the end of the day. All right, so we've got my, this is my bonus here. My payment is monthly. So let's change our colors here. Sorry about that. So this is what we're trying to do here. There we go. That looks better. So let me just make sure since I changed things up that my formula is okay. So I have my APR divided by 12, comma, 12 times 5, comma, minus PMT, comma, minus PB. There we go. All right. So now we're ready to goal seek. So we're going to go data, what if analysis, goal seek. We have R13. We're going to change that to 11,000 by changing our PMT. Now, since money will have cents associated with it, I'm going to expand my decimal places. So I ended up getting $122.28. So let me just show you the formula behind this one here. So this is the formula that we have in the background. Please note that we did change our end value to be 12 because we were dealing with monthly payments as well. We needed these frequencies to match up. All right, does anybody else have a question about you try number 1? All right, let's move to you try number 2. Ms. Klein has opened a savings account with 2.01% APR compounded monthly. She made an opening deposit of $1,800 and plans to deposit an additional $150 each month. How many years will it take for her account to reach a balance of $8,000? I want you to round your answer to the nearest hundredths place. And again, if you would like to have your formula nearby, you can come up and copy that formula just to have it in front of you until you get used to it. So we know that this is going to be here. So we have our, I'm going to mute myself as you're working. All right, I got 3.27 years. Is that what you guys got? All right, so Gabriella, let's look at this. So tell me, what part are you getting lost at? Okay. Your caps was on. So just the values to put in. All right, so this is when I'm going to be putting in my goal seek. So that first cell, when I do data, what if analysis goal seek, these values here should match what I have here. So the first input, the set cell, should be the FV. So that's going to be Z13. Or if you want, you can just highlight Z13. The 2 value is what we want the FB to be equal to. The FV should be equal to 8,000. So we're going to type in 8,000. By changing the cell we're looking for, since we're looking for the years, we're going to put in Z10, or I can just highlight that and we hit OK. So this will be the FV cell. What you want FV to be. And this would be the blank cell. Nancy, did you check your email? You should have received the spreadsheet in the email. All right, the question is, last question, for our initial formula, are we putting in place for the missing number? So for the missing number, when we first start, it'll just be blank. You can do blank or you can do 0. Most of the time, I just start with blank. So then when I do my goal seek, it's still able to give me that amount. So you either start with 0 or blank. Either one will be suffice. All right, let's move on to you try number 3. All right, so I have all of my input parameters. We're looking for the APR. So I've got my formula in. I'll just show you what that looks like. It's a long one here because I'm in the double letters over here. And now I'm ready to goal seek. So I'm going to highlight the formula with my cell. I said that backwards. I need to highlight the cell with my formula. We're going to click on what if analysis, goal seek. So we have AH14. We're going to set that value to $19,000. That's how much we're trying to save up for a motorcycle by changing the APR. So in order to get our APR, we're going to convert that into a percentage. So I'm going to click on this percent sign and I'm just going to expand my decimal places. We get 8.74% for our APR. 8.74%.
Yeah, I thought I was wrong because I was seeing the numbers in zeros. I was like, what's going on here? Thank you for bringing that
Yep,
up.
yep.
And I did. I thought I had 9%, but I think it might. Maybe the question might say, what? Two dozen of places, or
Yeah, this one's set hundreds. So
okay,
it's
yeah,
not
yeah,
enough. Yeah,
okay,
yeah.
all right.
Yep. Now, just to give you some context about percentage rates. Now, before I go there, are there any questions about question number 3? And if I am going too fast, just remember that this is being recorded, so you can watch this again and you can pause it, start it at the beginning or where you need it to be, to go to the pace that you need to go. So I have a follow-up question about this one here. How realistic is this? Now, I don't know you individually. There's 5 of you attending today. So if you've never had to borrow money or have never saved money or put money in the bank and so forth, you may not have any context for these interest rates. But my question to you is how realistic is finding a savings account that has an APR of 8.74%? So he has 5 years or she has 5 years in order to save up that $19,000. And the only way for that to happen is if they find an account that has 8.74% APR. So my question to you is, does that exist? What are your thoughts? Yeah, Bitcoin. So yeah, that's way too high. So couple things. So earlier today I was teaching my class and I just asked them to Google like what is the average APR for a savings account? Just to see what comes up on Google. And look right there it is. 0.06%. This is a percentage. So it's going to be 0.0006. So that value that we have, if we just calculated, is not very realistic at all, is it? Now, Philip says Bitcoin account, and yes, that was where we would maybe look at some um, investments of some sort. Now, talking about Bitcoin, personally, I actually invested in Bitcoin at the beginning of the summer, just a small amount of money, just to see what all the hype was about, to see, okay, let's see what happens if I have a little extra money. Let's put it into Bitcoin. And so I did. And at the end of maybe, or towards the end of last semester, my money had more than doubled. But if I check my account right now, I have my phone, I can open up my app. I know the last time I had looked at it, it is not in the double digits anymore as far as doubling. In fact, the last time I checked my account, and now it says it has connection issues, um, the account actually was less than what I had started investing with. So, Bitcoin, maybe if I had cashed out earlier on and I had put in a large sum of money, if I had maybe taken it out in October, I might have made quite a bit of money. But right now, it is worth less than what it was when I originally started. I'm not going to remove it. I'm just going to leave it. And again, this is a very small amount of money I'm talking about, just to see how it does fluctuate over time. Philip says, I take my money to do business because it's not worth. What does that mean?
Yeah, so I was looking at a Bitcoin that you're talking about. I went to the store yesterday, and to take a Bitcoin out, they have a machine where it
Mm-hmm.
says Bitcoin, like cash machine.
Mm-hmm.
It's $44,000 for one Bitcoin.
Yes.
Okay, so that I rather do business if I have to save the money. I rather find some business to do this and maybe sell some water or something to make some interest out of it. Because this 8 point something, that's the only way you're gonna make. But if other banks are not giving, they're giving you less than that, then I'm not gonna put my money in there. I'm gonna rather use my money for some kind of business where I think I can reap some profit.
Yeah,
Yeah,
absolutely.
absolutely.
And which
Yeah.
is
Which
what
is
the
what the
stock
stock
market
market
is so
is so
popular.
popular. Yeah.
Yeah. All right, so let's move along to total invested and total interest. So, lots of times when we're doing problems, we want to know, well, okay, I made a lot of money, but how much money did I actually spend in to go towards the money that I made? So let's take a look at an example here. So we're looking at total amount that you have invested and how much interest you have earned. Now, to calculate the total contributions, this is the formula we're going to use. We're going to take the payment amount, PMT. We're going to multiply it by the number of times a year that we are actually going to pay it out, and then multiply that times the number of total years we're going to invest, and then we're going to add on the initial deposit. So here I have a scenario where I have this APR, I have compounded monthly for 10 years. I'm putting in $100 each month, and the initial deposit was $8,000. After that amount of time, I've already got the formula in here. My account now is worth $26,108.02. So what were my total contribution? So we're going to calculate this amount by taking our payment 100, and we're going to multiply that by our N, which is 12, and that gets multiplied by the years, which is 10. And then we're going to add on to it the original deposit of $8,000. So from here, we see that I have invested out of my own pocket $20,000. So it's not like 8,000 turned into $26,108. I actually invested $20,000 because each month I was paying in $100, and I did that each month for 10 years. So the total amount I contributed was 20,000. Does that make sense? Now, if I want to calculate how much interest I've earned, so how much money did I make off of this investment or this savings account? So the total interest that was paid to me, we're basically going to take our future value or our A, whichever, and we're going to subtract off how much we contributed. So we're going to take our FV value, subtract off our total contributions, and we find that we earned a total of $6,108.02. And, this unit, we are going to talk about taxes. This is where you'll have to pay taxes, right? Because this is the money that you made. And believe me, the government is going to want their share. So when you make money, they make money. Any questions about these two concepts? We're just going to practice those and then move on to our total and annual return. All right, let's take this you try number one. It says, suppose you invest $5,300 into an account. You make additional monthly deposits of $125. How much money will you have personally contributed to the investment in 4.5 years? And then over this period of time, how much interest was earned? So I'm still going to start with my same set of values. I do not have an APR here, so I'll just black that out. My N is going to be 12 because I'm making monthly payments of 125. Now the amount of years is 4.5 years. And my initial investment was $5,300. Now, do I have enough information to find the future value here?
I would say no because you don't have the APR.
I agree. So I can't calculate this. So for this scenario, I only have these values. I can't even goal seek either because I don't even know what my future value is supposed to be. So, but I can calculate my total contributions, right? I don't know what's in my account after 12 years. I don't know what my interest rate was, but I do know how much I've contributed. So we can put that in. So that's going to be our PMT times N times Y plus the PV. So we have contributed $12,050 into this account. When it asks us how much interest was earned, you would say there's not enough information. That's kind of like a trick question here. We don't know what the interest is because we don't have a percentage rate and we don't have a final amount, so we can't calculate that. But we do know how much we contributed to the account. All right, here's our next one. In you try two, it says, suppose you deposit your $2,500 bonus into a savings account that here's an interest rate of 3.55% compounded monthly, and you also add in $75 each month. How much money will you have in your account after 5 years? So let's calculate how much money is going to be in the account after 5 years. Find the total contributions that you have made as well as the interest earned. I'm going to mute myself as you work through that problem.
I got an insanely large number.
All right, let's take a look. So we have an APR of 3.55%. where we have monthly compounding, and we're also doing monthly deposits of $75. Our years are 5 years. Our initial deposit was $2,500. So let's type that in. So we've got FV is equal to APR divided by N, comma, N times Y, comma, minus PMT minus PV. So,
I forgot to divide.
that makes a difference. Yeah, that's it. I think that's why it might be useful for us to like keep that formula in front of us, right? Like just go ahead and, oh, I guess I didn't copy. Keep that in front of us so that we can see it. Oops. Here we go. So now our total contributions. So that's going to be PMT, our payment amount, times N times years plus PV. So just to write this out, so that's what that is. And what we did was we said PMT times N times Y plus our PV. That's what we've done. The total interest, to get that, we're going to take our A or our FV and we're going to subtract off our total contributions. So that's going to be that 7,995 cents, subtract off 7,000. So this is going to be our interest accumulated. How are we doing out there? All right, we only have one more tab to go, and that's the total and annual return. So if you've been working through your Desmos, some people have had some questions about that. I've seen those on the ILC chat, and so I definitely want to take time to go over this before we leave our session today. So what is total and annual return? Well, most of the time we ask about total return and annual return on an investment as opposed to, let's say, a savings account. So an investment could be like a home, an antique car, or piece of artwork, whatever. It could always be Bitcoin as well. That's an investment where we're not so sure about the predictability of that investment. We probably select things to invest money into so that our hopes are that it increases, but sometimes it goes the opposite direction, hence the Bitcoin. Um, so there are two formulas that we are going to be using, and these are formulas that I would also write on my note card. We have the total return. Basically, it calculates the return on the investment from the beginning to the end. So this is kind of like a percent change. Now, in order for you to calculate the total return, you're going to take this value, and then after you calculate it, you're going to then multiply it by 100 and turn it to a percent. So let's take a look at this investment here. Suppose that I had an investment where the initial amount, so this is the starting amount, it was equal to 8,000, and then the end amount was 19,500. And now I don't know what this investment is. This is just showing me what it was at the beginning compared to what it was at the end. So I can find the total return or that percent change. And how I'm going to do that is I'm going to say equals parenthesis. I'm going to take my end amount, my A value, subtract off my P value in the parentheses, and then divide by that P value. Now, when I do that, this is going to give me some sort of numeric. But in order to convert that into a percent, we need to take this amount and multiply it by 100%. And it didn't do it, did it? Let's try that again. Where's my percentage at? There we go. So I have to change my formatting to percent. So basically we want to multiply this number by 100. And that's going to give us 143.75%. So this is how much this investment grew over some set period of time. Now we don't know what that time is. It's just giving us our percent change from the beginning to the end.
Can you write to the side how you entered that into Excel, please?
Yes, absolutely. So it's kind of like this. It's like we're going to take the A value, subtract off the P value, and divide by the P. That's what we're doing. But we have to turn that into a percent, so we multiply it by 100, and that turns into 143.75%. Likewise, we have annual return. And what annual return is, if we know how much time has elapsed between the beginning and end amount, we can calculate like an APR. Like if you were to, basically it's just saying that if you had put this into a savings account, this would have been the APR that would have given you the same output. So here in this example, it says determine the annual return on this 20-year investment. So again, I have those two same amounts. This is my, I guess I could just copy this like this, couldn't I? We got my initial, we have our end amount. And to find the annual return, we have something different. So I'm going to write out to the side what that equation looks like. So how do we input this in? Let me format, increase my
Karen, can I
font.
ask you a question real quick?
Yes, absolutely.
So on the problem above, I
Hmm.
got one what's in money. It's $1.44.
Okay. All right.
So
So
what do I need to do?
okay, so total return will not be in money because we're
Okay,
dividing. So the dollar units are going to cancel out, leaving you with nothing. So this really has no unit whatsoever.
okay,
And so basically just make sure your formatting is general.
got it,
Yep. Then you're going to multiply it by 100, and that's going to give it a unit of percent because we're
got it.
multiplying it by 100%.
Thank you.
You're welcome. All right, so here we have this crazy looking equation for annual return, and this is an exponential. So the base of the exponential is A divided by P. So what that looks like, it would be in parentheses, you have to take the value of A, divide it by P in the parentheses, and then you have to use that caret, and that is shift 6, by the way. And then I'm going to have another set of parentheses, and you do 1 divided by Y in that parenthesis, and then you subtract off 1. Now, because we have PEMDAS is going to take care of the exponent first and then subtract off 1. So don't be um, fooled here to think that minus 1 is coming off of that 1 minus y. It is not. It is subtracting that whole exponent by 1. So we're going to type this in. It would be equals our A value, and I've already forgot my parentheses. We need parentheses in here. So we have parentheses A divided by P in the parentheses. We have caret, parentheses, 1 divided by, now I didn't have the number 20 anywhere, so I'm just going to type in 20. and then minus 1. And I will put that equation out to the side. And again, I typed hard coded the 20 because I didn't have 20 in a cell to pick up. So I am going to take that annual return and multiply it by 100%. And then I'm going to turn that into a percentage. And that gives me an APR of 4.56%. So that would be my annual return if it were treated like a interest rate.
And I'm back to money again.
Mm-hmm.
I don't.
And yeah, it's okay. It's just the formatting behind Excel.
Got it.
So you can explicitly change that to a number or general. And the reason why it's probably I don't know why it's using number unless it's formatted for a number at the very beginning. And again, Excel might be trying to infer something. It does that a lot. It's trying to think about what this calculation is. And maybe based off your units, it's saying, oh, well, this has to also be dollars. But then sometimes you have to override what Excel does and say, no, it's not dollars, it's just a number.
I'm doing something. Go ask your sister to help you. Yes. Sorry, guys.
That's okay. All right, let's work these last two examples and then we'll head out for the day. It says the Johnsons bought a house in 2005 for $210,000. They raised their children in the house and lived there into their retirement. And then 2021, they finished paying off the mortgage. They had the house appraised and they were told the house is now worth $450,000. What is the total return on their house? Now, for these, we only need A, which is the same thing as future value, and we only need P, which is the same thing as PV. And it doesn't matter which order you go in. If you want to keep it in the same order which we've been doing, that's fine. Just note that the P is going to be the original, and then this is going to be the end amount, final amount. So in 2005, so that's the year that they purchased their home, the original amount was $210,000. Now look, see mine, it changes to a percent, and I don't want that. So I'm going to change this to currency. I'm going to change that back. The end amount is 450,000. So now I'm ready to find my total return. So my total return is going to be equal to, so we're going to do equals parenthesis our A value minus our P value divided by our P value. And see, just like you were having that problem with the dollar, right? Like it changed to dollars. I'm going to change this to general. And I will show you the formula over to the side. So this is what we're using. So my total return is going to be this amount times 100%. And then I'm going to format it to show a percentage. So from 2005 to 2005 to 2021, they had a percent change or a total return of 114.29%. So for those of you that came in after we got started, please make sure that you fill out the pre-survey. It's in the chat. Just quickly fill that out. So I have that data to collect and send on to the ILC team. And before we leave here, we're going to also do the post survey.
Can I ask you one question real quick?
Yes.
So when I do the total return and I do the calculation times 100, I'm getting 100, like 11,429%
Okay.
total return.
Okay. Are you in this cell here with the, or are you in this one?
I'm in the cell with that number.
Okay. So if you put the times 100 in here and see that
Oh,
that turns that to that, because if you've already multiplied it, then I don't need to multiply it here.
got it.
Yeah. And so, and basically it's treating this number like a let's see here what's doing. Let's see here. So we've got this number here. So if we do equals this, yeah. So it is okay. So when you convert from a number to a percent, you multiply by 100, right? So because I've already multiplied it, it's multiplying it by 100 again. So we don't want to do that. So I'm just going to undo that. And either we are going to let Excel do the conversion for you, or we're going to multiply. So let's see here. So if I just do, let's do this. So let me change this back to general. If I just set equals this and hit enter, and then I change this to percentage, it automatically multiplies by the 100. But if you do just times 100, it treats it differently. So what you can do is just do a reference back to that cell. Like notice I have nothing else in here other than this cell, and I just changed it to percent. All right, you try number 2. It says the Johnsons, it's the same scenario, except now they're wanting us to calculate the annual return. So here we have to have the years. We have our PV, which is P, and we also have our FV, which is A. And I'm just going to copy what I have over here. So we started out with 210, we ended up with 450, and the amount of years is going to be 2021 subtract off 2005. And again, this cell is formatted for a percent, so I'm just going to go change that in the background. So I just subtracted the years here. So now my annual return, and by the way, if you're heading out of here, I need for you to complete the post survey, please. So this is going to be your A value divided by your P. And we're going to raise that to the power 1 divided by your years. And we're going to subtract off 1. And I'm going to change that back to a number. Expand my decimal places. And I'm just going to set this equal here and then change this to a percent. So we have we have an annual return of 4.88%. All right, we are out of time, so I'm going to stop my recording.